Someone wanted to know what I meant about pickup risers, or P90 shims, from last week's video. Basically, the P90 dog ear pickup, in other words, the one with extensions on either side of the cover, was designed to be flush mounted on the top of a guitar. You see it a lot in 1940s and 50s Gibson archtops and any of the flat solid body guitars. Les Paul Juniors, SGs, SG Juniors, etc. They're designed to work with a fairly narrow range of neck angles. And Gibson is not always perfect when it comes to setting necks. There is some adjustability on these by raising and lowering the pull piece screws, but you can't lift the entire pickup like you can a humbucker. You know, you get a couple of millimeters. However, there are times when the geometry of the guitar is such that screwing the pickup down to the top leaves too much of an air gap between the pull pieces and the strings. Ideally, we want to see somewhere around 1/8 of an inch on the neck side of things, 1/16 of an inch if it's a bridge pickup. When there isn't enough clearance, it's usual to put a shim between the pickup and the top, like a little booster seat. You can buy them ready-made through various guitar accessory suppliers in a range of thicknesses. They are pretty expensive for what they are. They're also available in a number of shapes, most of which err on the side of super generous. This is an L5 you'll see in a future video. This being a black guitar, I don't suppose it was too much of a problem, but on a blonde example, having them so wide and just bulbous, it really sticks out like a sore thumb. You know, I'm not partial to the look, so I usually make my own. 3D printing to the rescue, right? Well, I predate the technology. I haven't got a whole lot of space, and though I appreciate what it can do, I'm probably not going to get into it at this point. The number of times I see people with like weirdly, badly distorted prints online complaining about how half their day is ruined. It makes me feel like I don't want to have that machine grinding away for 2 or 3 hours when I can cut one out myself and have it on the guitar in about 10 or 15 minutes. And if I mess up, it's because of me rather than, like, the print head getting off course somehow. The issue is the cover plates on P90 pickups differ from manufacturer to manufacturer. The dimensions vary. This is maybe 1 millimeter wider than this one. You see the corners are a lot more angular, less bulbous or rounded over, and it's hard to say, but I mean, they're frequently a little bit skewed in shape. You know, they're not symmetrical or identical. Could be the result of the molding process. Maybe there's some shrinkage, that kind of thing. To solve for this, I made a template that's about 1 millimeter wider in all dimensions than the cover plate I was working with when I made it, and that's done well for me. It's been fine for everything I've encountered so far. For material, I use this ABS plastic. That's acrylonitrile butadiene styrene. It's dimensionally pretty stable. It's flexible but still kind of stiff. You know, there is another plastic I'd probably prefer to use, and that would be Sintra, which is an expanded PVC, the polyvinyl chloride. It's used a lot in the sign-making industry. That stuff is a little bit softer, and I think it bends to arched surfaces a little more gracefully. But as those of us who used to collect baseball cards in the early 1990s learned, flexible PVC tends to have a whole lot of volatile plasticizers in it that leaches out over time and ruins your baseball cards. I can foresee issues with putting that up against old nitro lacquers. So this is the stuff I stick with. So this should all feel pretty familiar to those who've watched me do things. I'm going to put a few dabs of super glue in there. Pop the other piece in place. Hold it down. You could use an accelerator. I just don't like the smell. Just hold that for a minute. I can trim it close with a hand plane. Little plain curly cues are a lot easier and nicer to clean up than the chaff that comes off of the router, but I won't belabor the point. So I got my little router table set up with a happy little flush trimming bit there. As cute as can be. It's also dangerous as heck in my case. This thing doesn't have but the momentary kind of switch on it. It doesn't have an actual on-off button. So I actually have to clamp it on using a big old spring clamp and make all the shop teachers cringe. But I've been doing it for 25 years. I'm not going to stop now. Obviously, you have to know your way around this machine, know which way to feed the bit, keep your fingers as far away from the cut as possible, yet still applying enough sufficient downward pressure to keep it on the table. And yeah, don't do what Uncle Ted does. Get someone else who does this a lot to make one for you, okay? In a router table situation, where the router is upside down, we're always feeding the work into the router bit from right to left. So the bit is basically going clockwise around the work. Going into these tight little turns is a very dangerous kind of situation where you have to understand that if you allow the work to kick backwards, it can actually tear the work right out of your fingers and possibly drag your fingers closer to the bit than you want it to be. So if you were feeding in the wrong direction, that would be a constant problem. This is the kind of stuff you internalize after doing it for a long time. So that's what I mean when I say this is not a novice kind of job. You could also design a much larger jig that would hold the piece and allow you to cut one half of it at a time. Okay, now that we got little tiny bits of black plastic everywhere, before I take this template off, there are holes drilled into it for marking positions of the screws, which work well for a good many pickups, but as it turns out, not the one that I'm using. Yeah, actually, they're not really centered. Yeah, this one was fine. So I guess I won't drill the holes in it until I've taken it off the template. These other ones here are just sort of starting or stopping places for the inner recess. I got to cut out a good chunk of this, which I do by hand using a fret saw. And that looks like it's going to work fine. So I'll drill those holes. I can just do this by hand. I'm using a slightly smaller bit too. This shim happens to be 1/8 of an inch thick. Sometimes they have to be thicker, in which case I'll buy 1/4 inch plastic and sand it down on my drum sander. So I'll get this centered up by eye, because again, this casing is not really perfectly rectangular. The sides sort of bow in and out and everything. I have an 1/8 inch drill bit here, which is close to the hole size. The operation would be better with a transfer punch. I don't happen to own a set of those. That's okay, don't send me them. And just make myself a little mark so I can drill those out. I'll just test it out with a couple of screws. And yeah, I think that looks okay. I could go back and trim it even closer if I wanted to, but remember this thing is going to be under some bending force as well. And I think I'll leave it just as is. It looks good. Connect the dots. This is called a fret saw, somewhat ironically, if you work in guitar repair. Fretwork being that decorative sort of gingerbread stuff you see on the outside of Victorian houses, and this is one of the implements used for cutting that by hand. So we actually physically capture the piece on the saw blade, because I'm doing this inside cut. This is a bird's mouth, little V-shaped cutout on a table that supports the work, and sure that's locked in there carefully. And I'm just going to cut close to the line. Oh, it's nice after cutting other things like brass or ivory, stainless steel, mother of pearl. It just sings right through it. And go up to the next little hole. I can make a 90-degree turn. Okay, release the blade. I usually use a pair of pliers for this. Now I can go back to any spots where I'm a little shy of a line. I'll use a file. Well, this turned out perfect on the bass side. With the string depressed at the last fret, there's about 3/32 worth of clearance between the underside of the string and the top of the screw when it's lowered so that it's flush with the cover. However, on the treble side, if I push down the string, there is not enough clearance. I'm going to hit the front of the pickup if I'm fretting up high here. And there's only about a 30-second worth of clearance there. I need a little bit more. So I'm going to have to take this apart again, remove that, and sand it on the treble side so that it tapers from bass to treble. This is just the kind of thing that happens with archtop guitars. The tops are rarely uniform. There'll be one side that's higher than the other. One side will have sunk more. The whole, you know, it is what it is. Okay, I think that looks good. Got the right height with enough clearance over the front edge of the pickup when I'm fretting at the last fret, and I've adjusted the pull pieces so that we've got about a 1/16 of an inch between the E string and the upper pull piece, down to about 3/32 of an inch on the bass side. Happy with that. Now here we have a Gibson Les Paul. Quite a nice one. I believe this is the Les Paul Classic model from 1998. I think I set this up 3 or 4 years ago. Remember, it had a big ding in the neck that needed to be filled. Yes, it is still filled. That's good. So it's time for another setup and possibly a bit of chiropractic work to the bridge. So we'll take the usual measurements and see how it's doing. Action height. Looking on the bass side here, we have just about 3/64 of an inch, which would be about 1.2 millimeters. On the treble side, 1/32, 2/64, which is about 0.8 millimeters. That's good and low. To be honest, there are many guitars that can't actually be set up that low. This is doing pretty well for itself. Oh, I gotta show you guys this this thing I found. This is Case Candy, an original Gibson owner's guide from, I believe, the late 1950s. This was on Steve Olson's Instagram, Cone Tone Guitars. Haven't seen that for a while. I think he deleted. Anyway, I saved it, and I just rediscovered it the other day. These are the actual factory specs. Solid bodies like this Les Paul Standard that we're working on originally had 6/64 on the bass side, 4 on the treble. Archtops, 7/64 and 5. Your standard J45 flat top came to you with 8/64 on the bass side and 6 on the treble. That was the spec. Today I have people coming to me for neck resets with action heights that are lower than they were when they were new. Things change. And in terms of neck relief, we've got about 8 thousandths-ish, which is not bad. This player likes pretty heavy strings. Yeah, it looks like he's running a 10 to 52 set to be like a light top, heavy bottom, which is, you know, it's substantial. Unfortunately, it seems like the bridge is starting to sag. when it gets to the top, it's too tired to rock. This is common. Most ABR 1 style bridges, this original style, they're made from fairly soft metals. Aluminum, Zamac, which is a zinc alloy, or brass alloys plated. Over time, the incessant pressure from the strings, well, it can make them bow downwards in the center. And you end up in a situation where the middle strings are closer to the fret than the outside ones. So you'll get weird buzzes on your G and D strings, and it's just kind of inconvenient. The saddles in these bridges are stepped in height to approximate the 12-inch radius of the fretboard. So if the center bows down, those middle strings, they're going to get closer to the frets. You know, if we jack up the height to compensate, that leaves the outside E strings high, which is psychologically damaging to a good many people. Can we buy a new bridge, just pop it on? Yes, always an option. But there is a remedy. We can try and bend this back into shape. Will it last forever? Probably not. I saw a guitar recently that I did this thing to 7 years ago, and it's still holding. So I think it's probably worth doing at least once. I mean, you can't go bending things like this back and forth, because you're going to end up with metal fatigue, and it's just going to turn into a rubber band or break or something. But, you know, if you get an extra 7 years out of one bridge, which is otherwise fine, then yeah, why not do it? Before I take the strings off, there is something else we can talk about, and that has to do with the tailpiece here. You can see that this one has been set right down on the level of the body. It's been decked. And this is a practice that's been going on forever. Conventional wisdom being that this is one way to maximize sustain on these stop tailpiece guitars. It also increases the break angle over the saddles to its fullest extent. Mike Adams, Pusheen here on YouTube, he sent me some thoughts the other day for a kind of peer review about break angle and things that he's noticed and tuning stability on Gibson guitars that are really kind of profound, and I'm very much looking forward to the video he's putting together about this. Anyway, this being a common practice, I'm okay with it as long as the strings aren't contacting the back corner of the bridge, which is something that occasionally happens if the neck angle is really high. I mean, Gibson neck angles, they can be inconsistent over time. But with the beefy strings, it might also contribute to the bridge collapse or sagging. So this kind of setup can also give the strings a different feeling under the fingers, as if the strings were a little bit stiffer. Now, if you talk to physicists, they will likely tell you that changing the after length of a string doesn't change its actual tension at any consistent pitch, but most people will feel a difference. You know, Gibson's short 24 3/4 scale length can make the strings feel a little more loose and bendy, and this is one way that people figure they can regulate that sensation, whether the physics backs it up or not. Just for my own amusement, I'm going to measure this break angle, and maybe it's something to take more note of going forward. My little bevel gauge here, and we'll see what that is. Almost 22 degrees, which is a lot. Checking with the square, yes, it is a little bit caved in. Not extreme, I've seen worse. And yeah, it's dropped maybe a 64th in terms of the saddle height. So here's my jig for re-establishing these ABR bridges. This one's got a clearance cut for the saddles there on the top, and this one has an arch that will push against the underside of the bridge and get us back to level. They both have magnets sunk into them so that they'll stick to my bench vise. This is made from some dense tropical hardwood. Can't really remember what it was. Ipe maybe. So I'm just going to give that a bit of a squeeze. Not too much. Okay, that's close. Maybe a little bit more. Okay, it looks like it's pretty close to dead flat now. And the radius described by the notches in the saddles is now much closer to 12 inches as well. We'll give the pickup covers a gentle sort of a cleaning. Go too far and you end up scrubbing off the plating. There's a bit of schmutz on there. Polishing, polishing, polishing. Okay, got some new strings. Check the intonation, which was still good and solid. And yeah, the player mentioned that he thought maybe the saddles were a little bit loose and would come out. I couldn't make that happen. Over time, just the accumulation of grunge can act like a glue, but this is actually a fairly clean bridge. Sometimes on these old style ABRs that don't have the spring on them, if that's a problem, if they get really rattly or they come out, I'll take a drop of de-waxed shellac, just regular shellac, and use that on them. It acts like sort of a glue. It's not like Loctite, it's not like super glue, and it will chip off if you actually have to adjust the intonation. If you want to remove it entirely, you can soak it down with a little bit of rubbing alcohol and it'll come right off, but it acts like a gentle sort of adhesive to hold the parts together if necessary. Like I say, in this case I can't make these drop out like he was saying. So, isn't this a beautiful color? I think it's great. Gorgeous guitar.